This is Snake Arena, a grid-based snake game built in Haskell using Gloss graphic library. In this video, I'll first show gameplay and the features. Then I'll explain the program structure and the main technical decisions. Core gameplay is classic Snake. The snake moves on discrete grid, eats foods to grow, and the game's end if it hits a wall or itself. Movement control using WASD keys or the arrow keys. P key move, pauses and resumes. From game over, R key returns to main menu. The UI shows score, high score, length, current difficulty, and the health bar. The arena is bounded by decorative brick walls, but collision is computed in grids coordinated to match the playable arena area. The game supports easy, normal, and hard. Difficulty is not only speed, it also changes scoring, obstacles go thread, soldier spawn rate, and the power up duration. Easy, slower movement, lower score multiplier, obstacles and soldier spawn less frequently. Normal, medium speed, higher score multiplier, moderate spawn rate. Hard, fast speed, highest score multiplier, obstacles and soldiers spawn more frequently, and the power up duration is shorter.
Food is the red dot. Eating it increases length and score. Power-ups spawn occasionally. Speed boost temporarily reduces the move interval. Score multiplier doubles the point per foot during its active period. Heart restored health back to 10. So those are the power-ups. And obstacles spawn progressively based on score milestone. Obstacles are not single blocks. They are shape patterns such as L, T, Z, line and others, placed as connected clusters.
A custom obstacle type called soldiers is implemented. A soldier has position and facing direction. After spawning, each soldier continuously fires bullets along its direction. Bullets move faster than the snake and are updated every frame using time accumulator. When a bullet hits at any snake segment, health decreases by 1. Health starts at 10 and game ends when health reaches 0. The snake can eliminate soldier by moving onto the soldier's cell, which removes soldier from the game and gives a score bonus that scales with difficulty. High score is persistent between runs. The game reads the high score from a local file at startup and writes a new value when its current score exceeded it. This keeps the high scores across the program restart. The code is split into clear modules. Data type patches defines the core types: game state, direction, difficulty, power type, soldier, bullet, and replay. Processing.hts contains pure game logic: input handling, tick updates, spawning, collisions, scoring, and the soldier bullet mechanics. Main.hts contains rendering and I/O integration using GlossPay.io. It draws background, brick walls, HUD, snake, food, power-up, obstacles, soldiers, bullets, and health bar. IO handlers.hts contains file IO for high score and replay logs. Utils.hts contains common helpers like grid conversions, bound checks, random position generation, and analytics helpers. The game is driven by Gloss Play IO, which uses 3 core callbacks. Render IO, render the current game state to a picture. Handle input IO, processes keyboard events and update the state. Update IO, steps the simulation forward based on delta time. Even through Play I/O enables I/O, the design keeps the main logic functional. Processing.ts updates the state by producing a new game state from previous one. I/O is used mainly for reading and writing high score and saving replays. The game uses discrete grid for all gameplay decisions. Positions are int and int grid coordinates. Rendering converts grid coordinate to a screen coordinate using a fixed cell size and a vertical offset to align with the HUD area. Collisions are always computed in a grid space. Wall collisions uses an inbound function based on grid width and height and the playable area. Self collisions check the new head positions against the snake body. Obstacle collisions check against the obstacle cells. Random spawning avoids invalid cells. A margin is applied so food and power-up do not spawn inside brick walls. Soldier shooting uses timers. Each soldier has a shoot timer that counts down by DT. When shoot timer reaches 0, a bullet is spawned at soldier's position with soldier's direction, and soldier timer is reset. Bullets uses a speed accumulator. Each bullet has bullet speed. We add DD times bullet rate and convert the integer part into grid steps. This allows bullet to move multiple grid cells per second consistently even if frame time varies. Hit detection is performed by checking the bullet positions against the snake cells. Bullets are removed if they hit the snake or leave the playable bounds. Difficulty is represented explicitly in the state as difficulty value. The difficulty is used to parameterize base movement speed, scoring multiplier, obstacle spawn interval and maximum count, soldier spawn interval and maximum count, and power-up durations. This provides clear separation. Change in difficulty changes multiple parameters without duplicating logic across files. To build the project, we use kbar. From the project root, we run following commands. Kbar build, kbar run snake area. The code is compilable with GHC 9.6.x as configured in the project.